Hi, my name is Meredith Ebbs. I work for the Nature School in New South Wales, and I will be talking to you about learning outside with STEAM. This is a really quick presentation. It's only 15 minutes, so I am just going to jump straight in and I'm going to talk about my projects. STEAM is a pedagogy. It is not a curriculum area or a sub-syllabus area. It's a way of teaching. It's not STEAM days. It's not one day where we teach STEAM. It's actually a way of teaching all the time. And what you do is you take two of those subject areas in that acronym and you build projects around that. So a lot of my projects will refer to one or two or three of those areas, and then I usually build on them by having follow-up lessons in related areas. The first project I'd like to talk about is the Cardboard Challenge. If you haven't heard about the Cardboard Challenge, you can Google Kane's Arcade and find the inspiration for the Cardboard Challenge. This was done on the first day back. We'd been doing a literacy unit on Willy Wonka and the Chocolate Factory. So the students were asked on the first day back after lockdown to make a chocolate factory out of cardboard. These girls here made a ticket machine, and this is the on switch. Go. So that project was run by 3 blocks of code. So for year 3 and 4, this is a great way to introduce coding. When spacebar is pressed, play a sound and repeat it 3 times. And that way you have a practical application for students to incorporate their technology. Incidentally, those girls did not consider themselves very good at technology, and they actually really were excited when it actually worked. Some of the applications for the switch, which you can see there in the left-hand side, is that the students came up with was it could be converted into an alarm to put near the burrow of an endangered animal that would alert rangers to predators and illegal hunting. It could be put on the entrance at a service road to national parks so that it could alert rangers of unauthorised entry. And as a sign of the times, they thought it could be used as a countdown timer for washing your hands for 20 seconds. Down in the right-hand corner there, you can see I've got tile 3 and 15. They are Sustainable Development Goals from the United Nations, and I've got more information on those at the end, but I do map a lot of my projects to the Sustainable Development Goals, and there's a lot of really good information online about those. This is a science investigation. The students had to use the equipment to come up with a design idea. We were talking about rivers and river health, and we were talking how mangroves actually assist with river health by keeping nutrients out of the river. So mangroves are a really important part of a river system. And this was important because the tree line at the back there that you can see past the grass was actually part of the bushfires in Port Macquarie. So it was quite relevant for the students at the time. When you pour dirty water into the top of that cut bottle, there was mulch, dirt and sand, and that acted as a filtration to trap out the solid matter and some of the dirt. While the dirt in the bottom of the bottle looks dirty, it actually is a lot cleaner than it was. So part of the secondary follow-up to this lesson was during lockdown, the students had to redesign this project and find out ways to make the water even cleaner. So the students had already started to devise ideas on this particular day where we talked about adding layers, adding finer filtration such as cotton wool balls and fabric. And so there was lots of discussion about how to improve this filtration. This was all linked to a unit on rivers. Our book was a visual literacy unit using Trace Barla's River Time. And in that book, the boy who's the main character made a ladder out of vines using an Indigenous rope technique. So we taught the students how to create this rope, and you can see it's being done there with some raffia, but we did it multiple times. So we did it on site with raffia, and when we went to the bush one day, we did it with grass and with leaves. And what the students were able to then do is compare the quality of the rope with the different materials. They could also compare how easy it was to make, the time it took to make it, and its strength. So we also not just made rope, we also made crowns. And the crowns were looking at how to weave and manipulate grasses and raffia to make an actual product. And we also saw sticks and branches and built prototypes to construct shelters, which were also in the book. So the learning around that was measurement, strength of rope. You could follow that up more by using actual competition on how much could the ropes hold before they broke. And surprisingly, a piece of raffia is quite strong when it's plaited together in the cordage technique. What's the best what's the best material for the job? How much rope and timber do we need? Why do we use and where will we get and will we need commercial rope? Design and time. And the students decided the only reason you'd use commercial rope was purely because of the time it takes to actually make enough rope. Fractured fairy tales is another great topic that you often see on STEM sites, but I haven't yet to see someone who goes outside and actually builds a stick house for toys or for themselves. I'm yet to see someone who actually makes mud bricks or clay bricks and then creates a structure using those. And students also then go and investigate designs on how the pigs may have constructed their houses using these materials. Gardens are a common thing in most schools. And so we've got a kinder kitchen where the students learn to cook. We've got which involves measurement and reading. We also have investigations with our living things. This picture here is actually all the vegetables that grew during remote learning. So it's fairly crazy how much those plants grew when there was no one around to interfere with the vegetables. Future projects this term include soil moisture testing. So we're looking at how to use microbits to do soil testing on the soil moisture. And you could also look at the size of vegetables. And this project would be linked to Zero Hunger and Life on Land. Young ICT Explorers is a competition, and one group of students entered this for me last year. They had a radio transmitter using microbits to detect illegal dynamite fishing on coral reefs. And they assumed that when dynamite goes off, it would make the water rough. So they used the on-shake function in a microbit to actually detect when the water surface was disrupted. To distinguish this from a storm, they decided the ranger would need to know what the weather patterns were for that space and that area, and whether there were storms predicted. Microbits are one of my most favorite tools, and the rest of the projects are all about microbits. But microbits are really affordable. They're $30 each, and they have lots of great functions. And the brand new ones that are out now have a speaker and a microphone attached to them as well. So they're much better for value for money. So at the moment, what I'm doing with my Year 3-4 class is we're doing surveys and data in maths. So what we've done is we made a program, we created a variable called counter, and we made a counting or data collector using the microbits. So we actually took this microbit to the beach and we actually used it to count living things. Unfortunately, it was a rainy day, but what happened was we saw things we wouldn't normally see. So we're going again next week and we're going to compare what we saw on the rainy day to what we saw on the warm, hopefully fine day. This code is set to reset the counter when you start the microbit or attach the batteries. When you press A, it will change the counter by 1. It will display that value, pause it for a second, and then clear the screen so you're not wasting the batteries. So the survey is data. We use technology for coding. And then the next day in maths, we created a tally table which visually represented what we had found. And then today we made a graph of the results of what we have found, and we did our interpretations of our graph. And this was linked to life below water and life on land because one of our categories was sharks and dolphins, and we saw 12 sharks and about 15 dolphins, which was absolutely fabulous. I actually have never seen that many sharks in the wild before, so it was quite exciting. Another project idea is a compass. So a compass, a simple compass, you would be with stage 2, you'd be talking about direction and you'd be focusing on direction. And they won't necessarily understand the angles that you and the degrees that you're putting in those boxes, but we could use the compass then to create our own map of the school, to using mud maps, or to navigate and have a simple orienteering course or a scavenger hunt of sorts, where we give instructions to a friend and they have to then move to find things that are being hidden around the school. Stage 3 or 4 could be looking at the geometry around your compass work, and our stage 3 class will be looking at geocaching, where they actually hide geocaches and talk about degrees and bearings and things. So you can incorporate that really well. You might need to build some sort of device to hold your MicroBit. A pedometer is a really great way to measure steps, and the maths around this is about measurement, and it's about looking how far does one step take, how far is 500 steps, and talking the measurement of walking and distance. So this is a coding activity. Your science and design activity could be about creating some sort of band or holder to hold this, and an investigation on where is the best place to wear this. So if you think, for those of you who don't know what a microbit is, it's about it's a little device. It's about 3 by 3 centimeters, and it's got lights on it and some buttons. It's a little piece of technology, a bit of a board. So you do need to have a safe place to wear it. So that would be your investigation. Is it better to hold it, put it in your pocket, attach it to your shoe? And how does it function compared with an Apple Watch or a Fitbit or a Garmin? So these are all questions you could ask in an investigation. Just a heads up, it is best placed on your shoe because it is on shake. So the best part is when you run or walk, it's actually going to jiggle your microbit enough to trigger the count of the steps. This is a hot and cold thermometer that I did with stage 1, and stage 1 just had its symbols, pictures coming up. And the reason the temperature is so high is because I live in a warm climate. This would be another thermometer that has conditions. It has maximum and minimum, and this would be a stage 2, upper stage 2 or stage 3 program. And when you do this, you might create an investigation where you investigate or compare a microbit thermometer to a regular thermometer or a weather map and see how accurate these microbit thermometers are. This is the code for a moisture sensor, and the moisture sensor is it's a little bit difficult for stage 2, but it's something that they can do. It's great for stage 3 because you have to describe what an analog pin is, which is actually the gold bar across the bottom of your microbit. That can be used to collect scientific data and used in investigations. Sustainability development goals, there's 17 of them, and they're set by the United Nations, and it's about working toward having a better world for everyone. Outdoor STEAM projects bring opportunities for real-world applications. Taking your projects outside actually brings in a real new focus for actually teaching your projects. Now, not everybody works in a space that is actually going to allow them to do what I do and go to the beach or go to the bush, but you can do it in your playground. You do have a way of incorporating what resources you actually have close to you. You might have a park nearby, or you might be near the beach, or you might have a national park close by, or a creek. So using those resources that are nearby to you to actually teach your projects, make it more relevant to your students. It's about throwing out your textbooks, throwing out your worksheets, making sure you don't have photocopiable packs for science and technology. There is nothing more boring for students than photocopied packs. This is about actually having your investigation and your project as your main focus in your unit, and then building on that by then maybe having some students interpret different data or interpret understanding or do some research. There's some resources for you. Please feel free to contact me anytime on social media. Thank you very much. Goodbye.